This is Algebra 2 with Trig, 2b.1, talking about properties of exponents. Here's a little chart with many of our properties. The multiplication rule with working with exponents. If you're multiplying the same base, A and A are the same base, you can consider that like 2 to the third power times 2 to the fifth power. The same base, but with different exponents. They could be the same exponent, that doesn't matter. But we're going to add the exponents together to reach our conclusion. So it's 3 plus 5 gives us 8, so it's 2 to the 8th power. We look at the division rule. The division rule, here they're using the division symbol. I would prefer if they would write it as a fraction. That's the way we're going to typically see it. So what we're going to do is subtract exponents. The power rule. When you raise a power to the power, you multiply them. So you can think about this as like x squared to the third power. Really, you could consider that x squared times x squared times x squared, because that's what the third power means. It says take what's inside the parentheses and write it 3 different times. Therefore, we would say 2 plus 2 plus 2 is 6. Well, you already knew that because 2 times 3 is 6. That's the shortcut, is to multiply if you're raising a power to the power. Notice that's different than what we did up here. This one was just 2 to the third power times 2 to the fifth power. We're multiplying the same base. So multiplying the same base, you add exponents. When you raise a power to the power, you multiply those because you're repeating that the same amount of times. So it's a time situation. It's a multiplication. The power of a product rule. This is where I say that you distribute that exponent in. You distribute it into the parentheses. But to distribute it into the parentheses, you hear a conflict of what we've said before. I mentioned before you cannot distribute into the parentheses. And that's when we were working with a binomial. You cannot do that. Cannot distribute into a binomial. This down here is not a binomial. This does not have a plus in between your terms. This is multiplication. That's called a monomial. So we can distribute it in and call it a to the x power and b to the x power. We can do the same thing for a fraction. When there's no exponent written, it's just a 1. So it's x times 1 is a to the x. And b to the first power to the x is x times 1 is b to the x. Any value to the 0 power is 1. Any power, or any, it's really a base. Any base to the 0 power is always 1. You learned that back in Algebra 1. You learned that in geometry. You now are repeating that in Algebra 2. You're going to also do that in pre-calc and calculus. You need this all the way through. A base to the 0 power is 1. Very important. Now this is a tough one. This one comes up a lot today. Negative exponent. Listen to what a negative exponent is. Negative exponent puts the value into the denominator. If it has a negative exponent, which you haven't worked with many of those in the past, this might be the new part for you. Putting that exponent into the denominator. The answer is not negative. The exponent doesn't stay negative, right? So if this is 2 to the negative third power, that means we're going to write it as 1 over 2 to the third power, which you could simplify that as 1 over 8. And then this last one is a fractional exponent. We're not doing that right now. We will come back to that. We will do that at a different time. But a fractional exponent, you look at your denominator, and it creates this radical, and the denominator is called the index. It might be a little bit new for you also, but we'll be hitting that more in the future. So for example, if you have 8 to the 1/3 power, a base to a fraction exponent, it gets created into a radical with the denominator as the index, the base is inside, and the numerator, you can actually write it inside the radical or you can write it outside the radical. It's correct in both formats. So this is the cubed root of 8 is what times what times what makes 8. That's what it's asking. 3 of a kind to make 8. So that's 2 times 2 times 2 makes 8. So that's why the cubed root of 8 is 2 to the first power, which is just 2. So those are all of our properties of exponents. So we're going to come over here, and we're looking at that one. How are you going to apply your property that you just learned, or you just saw, into this one? Which one does it match? Well, it's a fraction raised to a power. Well, that's a fraction raised to a power. What do? We distribute that value in. We're going to make it a to that power, make it b to that power. So in this case, we're going to distribute that exponent in. When we distribute it in, we multiply with the exponent that's already there. Now I see I have negative exponents. Well, negative exponents don't stay where they're at. This negative exponent's not happy there, so we're going to move it to where it is positive, where it's has a positive exponent. It goes to the top. This 8, this 1 really, has an exponent of negative 8. Negative exponent means that you're going to put it into the denominator. 3 times 3 is 9. Another 3 times 3 is 9. So 3 to the 4th power is 81. 1 times 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 1 is 1. So you could put that over 1, but you don't need to. It's just 81. Now we're going to look at example 2. What do you see? The math itself is simple. That's what I always tell you. The math is simple. But understanding what to do is the challenge. So you've got to come up with a decision of what to do. You can refer back to these videos to do your homework. Find the video that matches the question and copy it. Or you can work on trying to make your own decision on why you need to make your steps the way you do. So what are we going to do with that? Which one of these properties does this look like? What steps would we do? I have the same base. If I'm multiplying the same base, I add exponents. If you can do that on your own, then you are making your choice of what to do. And that gets you a lot farther. Five plus -8 is -3, and 6 more gives you +3, so that's w to the third power. All right. Make your decisions on what you would do here. If you're confident, write it down. If you're not, try to make your decisions mentally. But I hope you're getting some confidence to try to write down some stuff yourself. Don't be a copier. I distributed my exponent in. You multiply the 2 and the 4 to make 8. They're both negative, so it becomes positive. My c has a negative exponent, so it goes to the denominator. My 8 has a positive exponent, so it doesn't move at all. It stays put. So if I remove everything from one of the sides of your fraction, there is still a 1 left over. It's always 1 times c to the negative first. There's always a 1 there. That's more of a place value holder. Okay, what about our next one? So, when we start to work with these with multiple variables, what you want to focus on is one variable at a time. So this is a to the negative third, and this is a to the 5th power. You also have a b squared and no b's on bottom. So focus on one letter at a time. You might not need to write it separately, but you should at least be breaking it apart in your mind separately. I see that I have a to the negative 3rd power. So I'm going to write this as 1 over a cubed a to the 5th, because I brought the a cubed down to the denominator. My b squared was happy just where it was. So my final answer is b squared a to the 8th power. Okay, let's look at number 5. What do you see here? So we're going to look at this one here. A lot of people might make a mistake and think this is foiling because you have sets of parentheses. But there's no adding and subtracting. These are not binomials. These are monomials. We don't even need the parentheses. We have a 7. We have a y squared. We have a y to the negative 4. We have a z to the 5th. We have a z to the negative 1. So I'm just kind of grouping up our letters that are the same. If you would like, you could say that this was 7y squared with y to the 4 on bottom. This is z to the 5th with z to the 1st on bottom. Now I notice that I have y's on top and bottom. I have more y's on bottom than I have on top. I have 2 more y's on bottom than I have on top. Z's, I have z's on top and bottom. I have 4 more on top than I have on bottom. So I have z to the 4th. So our next one, we're going to distribute our exponent in. Even to the 2 here that has no exponent showing, so it's just a 1. So you multiply that exponent to all the exponents. To the 3rd power is 8. Don't really need the 1 on top. I have more a's on bottom than I have on top. I have 6 more a's on bottom. I have my negative exponent. So it comes down and it groups together with the 6, so that's a total of 9. Now I do need the 1 on top because it worked out just fine. So it looks like 3 times 2 should have been 6. My fault. 3 times 2 was 6. Negative 3, 6, 9. The rest of them are correct. Now it looks like I have 3 more on bottom, not 6 more on bottom. Thanks for noticing. All right, moving to number 7. Distribute our exponents in. I notice that my x's have the same, or obviously the same base. I have more, 12 is bigger than 9. I have more on top than I have on bottom. I have 3 more on top than I have on bottom. With the y's, I have a negative exponent, so it's going to come to the bottom, and when it comes to the bottom, it adds in with the 18. And that becomes 24. And the last one. You can work with the tops and work with the bottoms and then simplify, or you can work with one fraction and then a second fraction, whichever you like. I notice that I have more x's on bottom than I have on top, and my negative comes to the bottom to make y squared. My 7 is fine, my x is fine, my y has a negative exponent, so it goes to the top. So I have 7x cubed y to the 4th with my xy squared, and I need to simplify that. That tells me I have 2 more x's on top, and this tells me I have 2 more y's on top.